Basic acoustics terminology. Number 1. Wavelength. Wavelength is the distance a sound wave travels in one cycle. It is numerically equal to the speed of sound 344 meters per second multiplied by the period, represented as lambda equals c. Number 2. Frequency. Frequency refers to the number of vibrations occurring per second, measured in Hertz Hz. Number 3. Vibration cycle. A vibration cycle refers to the duration it takes to complete a single vibration. Number 4. Sound pressure. Sound pressure is a physical measurement that indicates the strength of sound, typically expressed in Pascal's P. Number 5. Sound pressure level. Sound pressure level. Sound power or intensity is proportional to the square of sound. Number 6. Sensitivity. Sensitivity is the sound pressure measured at 1 meter from the acoustic axis when a noise signal of 1 watt is applied to the speaker. Number 7. Impedance. The impedance characteristic curve shows how the electrical impedance of a speaker voice coil varies with frequency. Number 8. Rated impedance. Rated impedance is the minimum value that appears first after the maximum value on the impedance curve, measured in ohm. Number 9. Power handling. A speaker's sound quality is not directly related to power handling capabilities. Power determines how loud the sound can be, while overall sound quality represents how powerful and complete the sound feels. According to international standards, 2 main methods for measuring power are rated power, RMS, or sine wave root min square, and instantaneous peak power, PMPO. Number 10. Rated power. The rated power is the input power a speaker can use for extended periods without producing abnormal sound. Number 11. Peak power. Peak power is the output power calculated from the highest voltage the sound signal can instantly reach. Number 12. Sound coloration. Sound coloration refers to the alterations in a sound, resulting in characteristics that were not part of the original signal. This means that the reproduced signal may contain additional or fewer components. Number 13. Frequency response. Frequency response refers to how a system responds to different sound frequencies. The effective frequency response range is defined by the points where a straight line is drawn near the highest peak of the frequency response curve. This range is determined by identifying the octave frequency band within which the average sound pressure level drops by 10 decibels from that peak. Number 14. The loudness of sound. Loudness, also known as volume, refers to the strength of the sound as perceived by the human ear. It is a subjective experience related to the intensity of the sound. The amplitude of the sound waves determines the loudness of a sound at the reception point. For a given sound source, the louder it is perceived to be, the decreases as the distance from the source increases. Conversely, if the distance remains constant, a greater amplitude in the source produces a louder sound. Although loudness is closely related to sound intensity, their relationship is not linear. It is more accurately described as logarithmic. Furthermore, changes in frequency and the waveform of the sound waves can also affect how we perceive loudness. Number 15. Distortion. There are 3 main types of distortion: harmonic, intermodulation, and transient. Harmonic distortion occurs when high-order harmonic components, which were not present in the original sound, are added to the original signal. Intermodulation distortion primarily affects the tonal quality of the sound. Transient distortion arises from the lag of the loudspeaker and the vibrations of the speaker's structure, which may not keep up with the rapid changes in the electrical signal. This type of distortion is crucial in speakers and loudspeakers because it directly impacts sound quality. Transient distortion is typically expressed as a percentage, with smaller values indicating less distortion. For ordinary home audio speakers, distortion levels are usually below 0.5%, while for subwoofers, a distortion level of less than 5% is generally acceptable. Number 16. SNR. Signal-to-noise ratio measures the ratio between signal power and noise power. It evaluates a signal's clarity or purity in a noisy environment. A higher signal-to-noise ratio indicates that the signal is clearer despite noise, while a lower ratio suggests that the signal is more vulnerable to interference from noise. The signal-to-noise ratio is measured in decibels, dB, and calculated using the formula 10 log Ps. PN, where Ps and PN represent the effective powers of the signal and noise, respectively. Number 17. Pitch, tone. Pitch refers to the specific and typically steady tone of a sound, which determines whether it is perceived as high or low. It is primarily determined by frequency, but it is also influenced by sound intensity. When a person hears a high-frequency sound, they perceive it as a high pitch, while a low-frequency sound is perceived as low pitch. The relationship between pitch and frequency measured in hertz, Hz, is essentially logarithmic. Although different musical instruments can produce notes at the same frequency, the timbre of the sound may vary. However, the fundamental frequency remains consistent across these instruments. Number 18. Tone color. The perception of sound quality is a distinctive characteristic that sets different sounds apart. Various instruments may play the same pitch, yet their tonal colors vary significantly. This variation occurs because their fundamental frequency is the same, but their harmonic components differ significantly. Thus, timbre is influenced by its basic frequency and the harmonics. This is what gives each instrument and individual their unique timbre. Number 19. Dynamic range. The strongest to weakest sound ratio is expressed in decibels dB. For instance, if a band's dynamic range is 90 decibels, the quietest part of the sound is 90 decibels lower in power than the loudest part. The dynamic range measures the power ratio regardless of the absolute sound level. As mentioned, human hearing's dynamic range spans from 0 to 130 decibels. Similarly, the dynamic ranges of natural sounds vary greatly. Typical speech signals are around 20 decibels, while some symphonies can have a dynamic range of 30 to 130 decibels or even more. However, due to various limitations, sound systems often cannot achieve the same dynamic range as a live band. The internal noise of the recording device determines the softest tone that can be captured, while the system's maximum signal, capacity, distortion level restricts the loudest tone. Generally, the ideal dynamic range for sound signals is 100 decibels. Therefore, a sound system that achieves a dynamic range of 100 decibels is perfect. Number 20. THD. Harmonic distortion refers to the extra harmonic components added to the output signal compared to the input signal. This distortion occurs due to the system's incomplete linearity. The combined level of all additional harmonics is known as total harmonic distortion, THD. Total harmonic distortion is also related to frequency. Generally, the THD is lowest at 1000 Hz. As a result, many products use the distortion level at this frequency as their primary performance indicator. Number 21. Stereo separation. Stereo separation refers to the degree of isolation between two audio channels and precisely how much they interfere. This is typically measured as the difference in signal level between one channel and the amount of signal that leaks into the other channel. Poor stereo separation can weaken the overall stereo. Number 22. Damping factor. The damping factor measures the ratio between the amplifier's rated load speaker impedance and the power amplifier's impedance. A significant damping coefficient indicates the power amplifier's low output resistance. This coefficient reflects the amplifier's ability to control the movement of the loudspeaker cone after the signal has ceased. Amplifiers with a high damping coefficient behave more like a short circuit to the loudspeaker, effectively reducing its vibration once the signal has ended. Number 23. Frequency range. Treble refers to the higher range of sound frequencies, typically above 2000 Hz. Sounds in this range are bright and sharp, but usually quieter in volume. Mid-range encompasses the frequencies between bass and treble, generally ranging from 300 Hz to 2000 Hz. This range produces more natural sounds and is crucial for the clarity of musical instruments and human voices. Bass refers to the lower range of sound frequencies. Typically from 20 Hz to 300 Hz, sounds in this range are deep and heavy, creating a powerful and resonant impact. Bass is fundamental to the overall sound experience, particularly in music and sound effects. Low frequency, 20 Hz to 40 Hz. Mid-low frequency, 40 Hz to 80 Hz. Mid-frequency, 80 Hz to 800 Hz. Mid-high frequency, 800 Hz to 4 kHz. High frequency, 4 kHz to 8 kHz, ultra-high frequency. 8 kHz to 15 kHz, ultra-high frequency. 15 kHz and above.